the backup presentation. The presentation that couldn't be here, so we got the backup one. No. I'm here to talk to you about beyond backups, disaster recovery that works. And just a few bits about me. So I'm currently the principal resilience architect with a company called RPO. And I'm just working every week with multiple customers on their disaster recovery strategies. But I think more interesting is that my clicker is slow. But also more interesting is that I spent 14 years at Amazon, 5 of those with AWS. And during that time in AWS, I was the global reliability lead for AWS. So if you've read the disaster recovery on AWS white paper or referenced it, or the disaster recovery on AWS blog series, or who's heard of the shared responsibility model for resilience? Yeah, so I authored that. We did crib off the shared responsibility model for security, so we did have a head start there. So not all credit to me and my co-author, but yeah, so that's the kind of stuff I was doing, and I love talking to folks about their cloud resilience and disaster recovery strategies, and that's what we're going to talk about today. All right, so this is about disaster recovery of cloud workloads. And I'm going to be using a lot of AWS examples here. That does not mean this is just AWS. This applies to any of the cloud providers. It applies to Azure, it applies to GCP, it applies to any of those providers you see up there. If you're using a different cloud provider, it applies to those too. Just know I'm using AWS as an example, and I'll try to expand those examples as I go along, but don't let that put you off. All right, disaster. So if you come visit us, RPO, at a trade show where we're sponsoring it, we will bring the Wheel of Misfortune with us. And the Wheel of Misfortune has one light blue slot on it, wedge. And if you get that light blue slot that says a quiet day, you win a gift certificate. Every other slot is a real disaster that has befallen a real enterprise in the real world. So let's play a little game. I want to share with you what some of those slots say and see if you've heard of them. Okay, first one is cloud provider clean out auto deprovisions. I can't read it from there, but basically the cloud provider deprovisioned your account. You're down for, 90 days? 7 days. You're down for 7 days. Does anybody know what this is? This happened, the dates are really important. May 2024, somebody had their accounts deleted and was down for 7 days in the cloud. Have you heard of UniSuper? Okay, so UniSuper event was an Australian provider of retirement accounts. Google deleted their accounts. And then Google had to bring them back. They even, Google had to do like a post-event summary saying, yeah, we deleted their accounts. We shouldn't have. That was a bad thing. We're really sorry. It won't happen again. But they were down for 7 days. So that was a bad thing. All right, how about this one? Businesses refuse connectivity after hack. 90-day outage. This is a 90-day outage. February 2024. And if you don't know what this is, I'll give you some hints. It was actually a big data breach, and it was a healthcare provider or healthcare adjacent provider. Anybody heard of this?
United Healthcare.
Yep. United Healthcare, their Change Healthcare subsidiary was hacked. All the data was released. And the whole thing about businesses refuse connectivity, that's the part that didn't quite make the news. So even if they got everything back up and they paid off the ransomware, they were up and running, they sit between the doctor and the insurance companies. Nobody wanted to connect to them. They've been tainted. Nobody knew if they could trust them. All right? So you need a strategy that prevents that from happening. Okay, this last one, a little more recent. This is October 2025. Cloud provider DNS issues. Cloud services down 14-hour outage. Anybody remember that one? Pretty recent? Yeah, AWS, DynamoDB outage. Didn't affect just DynamoDB. Took down a bunch of services. Basically, you couldn't run your workloads in US East 1 in October 2025 during those days. And it started at midnight. Just to make it a little worse, have it start at midnight and everybody get paged and woken up. Midnight West Coast, right? All right, those are scary. I do not believe in fear, uncertainty, and doubt as a selling strategy or as a driving strategy. I don't want you to be afraid. I want you to know that I've been saying for years, production is chaotic. Whether you're in a data center or the cloud, production is chaotic and unpredictable. These things can happen, but you with the right resilience strategies, which in this case is going to be disaster recovery, can recover from these. Each of these things is recoverable without the bad thing that happened here. And if that's not enough to convince you, right, if you're just seeing the disasters, maybe taking the other side of the coin. So all the major cloud providers have what's called a well-architected framework that publishes best practices. That's actually what I did for a living at AWS. I was the reliability lead for well-architected. And those are 5 best practices, I'm not going to read them to you, you can read them, that AWS is telling you you need to do. Okay? It's not just me saying, hey, it's scary out there. AWS says if you want to run on AWS and you want to do it right, you need to do these things. And if you don't do it right, we're going to say you're at high risk. Right? That's the well-architected assessment right there. So that's the other way to look at it, why you should be doing these things. All right, I didn't give an agenda for the slide. I actually hate agenda slides, but the agenda is really simple. I'm going to have one section on the requirements. What does it take to do disaster recovery that works? And my next section is going to be implementation. What are the technical details on how you implement this thing? And then we'll summarize it up. So diving into requirements, this first slide is actually not a requirement. It's sort of an overview of what I want to build here. And it's a bit of an eye chart. I get that. But all those little colored squares and labels, it's a cloud native workload. It's beyond servers, right? It's using serverless, it's using containerized workloads, it's using cloud networking, it's just using a lot of stuff. And it's happily running, right? But on the right is a big blank area. I say we need to create this. What do we need to create? First step is we need to actually create a place to back all this stuff up. We're going to back up the data and the metadata and the infrastructure and everything you need so it's available from you need it. And the next thing we're going to do is set it up so that at the push of a button or the launch of a script, it all stands up again. The one on the right should look exactly like the one on the left, but now it's running in a different place. And we'll talk about what that recovery site looks like. So this is what we're aiming to build today. And so requirement number one is defining your recovery objectives. Your recovery objectives for disaster recovery are called RTO, Recovery Time Objective, and RPO, Recovery Point Objective. I'll start with RTO. It's a little easier to explain. So that's a timeline along the bottom of your service in the cloud running, and then the big flames, surprisingly, are the disaster, right? And then you can see there's downtime, and then your backup. So that's your recovery time. So your recovery time objective is the maximum amount of time that your service can be down after the disaster occurs. That's recovery time objective. Now RPO, recovery point objective, is about the data, and it's a little harder to comprehend. So it's more about, you see the dot on the left there, that's the last time you took a good backup of your data. So now the disaster occurs. So every transaction you took between then and then is lost. So it's a measure of data loss, measured in terms of time. So 1 hour RPO means you can have up to 1 hour of data loss. And in case you haven't figured it out by now, maybe you let me know if you figured it out, the name of my company, RPO, is based on RPO, which makes all the AI assistants that transliterate what you're saying completely confused, as they don't put our name, they put literally RPO. All right, now this is the requirement I was going to tell you about, the recovery site. Remember I said in that first big diagram, you got to recover somewhere. So you got to recover to a safe recovery site. This is what distinguishes disaster recovery from high availability. High availability, you might be across, if you know what availability zones, you might be across availability zones. But high availability is about replacing servers, or replacing individual connections, all done in place and relatively quickly. Disaster recovery is different. Disaster recovery is saying, I can't run where I'm running now. I have to run somewhere else in a safe recovery environment. And to talk to you about what that environment looks like, I want to talk to you about those are the three types of disasters that can occur. This is from my disaster recovery white paper. We define 3 categories of disaster. And those categories are still true today, and I stand behind them. But what I found after working with over years and hundreds of customers, there's really only 2 types of disasters that occur with any regularity. And by the way, disasters are relatively rare, right? They're just big scope. But amongst the disasters that do occur, these are the 2 main ones you could expect to see. One is regional outages, regional events, all right? And this is like the US East one I just described. That's a regional event. It doesn't mean the region is hard down. Regions generally don't go hard down. The exception is recently in the Middle East, a region has gone hard down. That's never happened before. But generally what happens with regions is there's a bug, there's a problem, and you can't run your workload there. So as far as you're concerned, it might as well be down, right? And for that, you need to recover to a different account, a different region. I got ahead of myself. You need to recover a different region. Different regions provide strong fault isolation boundaries. A fault isolation boundary means if one region has a fault, it's very unlikely to jump over to another region. So in the case of regional events, recovering to another region is sufficient and great. Now, I kind of get ahead of myself. The other kind of event we see are ransomware and malware. And we all know those are on the rise. We all know those are real threats. Going cross-region will not help you. Your account has been compromised. So for that, you need to go cross-account. And if you see on the bottom there, you got to go to an account with different credentials. right? The bad guys have your credentials. You need to go to an account with different credentials, a different key. All right, so you need to go cross-region, cross-account. And this next slide is just to show you that same thing applies for Azure. Same thing applies for every cloud. All right, so again, I said I'm going to be using AWS as my prime example. I do have some Azure slides, so I just thought I'd show you same exact thing. Azure has the concept of regions. Azure basically has the concept of subscriptions, which is kind of the equivalent of an AWS account. So in this case, we're going cross-region, cross-subscription. All right, our next requirement, and this may seem like obvious, but I don't think it is do complete recovery, recover everything. And I say this seems obvious, but it's not. There's a lot of folks out there who talk about disaster recovery, and they're talking about backup. And remember, the name of this talk is Beyond Backup. So let me show you what I mean by that. So here's a workload, multi-tier workload using about a dozen different AWS resources, happily running in a given account and region. Something bad happens. We already talked about what those bad things can be, right? So your customers are now upset. So we need to go cross-region, cross-account. We already said that. Oh, there it is. And we're going to recover your data, right? That's backup. But the customers are still unhappy. Recovering your data is great, by the way. If you don't recover your data, you can't recover. That's like a necessary table stakes, recover your data. But it's necessary but not sufficient, right? We also need to recover, we need to go beyond backup and recover your networking, your infrastructure, your security principles. We got to recover everything. But the customers are still unhappy. They still have question marks there. Those of you that are familiar with cloud services know I brought up these resources in a different account and different region, and now they have different names. The databases have different endpoints. The load balancers have different endpoints. It won't work. So now you also have to go through the configuration and remap everything. That's why it's a magic wand. Or we could use technology, magic or technology, either one. But you've got to remap everything in the configuration, and now the customers are happy. So that's what recover everything looks like. And we want it to be cost effective, not cheap, right, but cost effective. And I list 4 different types of disaster recovery strategies, and I'm not going to go through what each one is here, but I will say the ones on the right are more complex and more expensive, but have lower RTO and RPO. That means less data loss, less downtime. Sounds great, right? But cost more expensive. The ones on the left, cheaper, easier, but higher RTO, RPO, all right? And this is arguable. So this is not like Seth saying this is written in stone. This is arguable, but I'm going to say the sweet spot's here with what we call pilot light. Okay, a pilot light strategy, you stand up some things, you don't stand up others, and then when you need it, you stand everything up. And it certainly has the cost and difficulty benefits, right? It's less expensive, it's less difficult, but saying it's slower to recover, nobody's a fan of that, right? So let's talk about making it fast to recover. I think with the right orchestration and automation, you can make a pilot light recovery as fast as a warm standby. And also, pilot light strategy might be a little more complex than just a simple backup. So we're going to make it as simple as a backup. And the way we're going to do that, again, is orchestration and automation. I'm going to show you how you can have a pilot light strategy with the right orchestration and automation to make it as simple as a backup and restore, and almost as fast as a warm standby. And we're at a DevOps conference, so and this is a very important requirement, which is make it a platform. And in the open space yesterday, we concluded that there is no difference between DevOps and platform engineering, and I'm down with that. That's great. All I'm saying is that rather than write a bespoke recovery strategy, a bespoke recovery scripts for every one of your different workloads in the cloud, instead create a platform that does it all. And then teams can onboard to that, and teams can then own their own recovery. They can own their own onboarding, and they can own their own recovery. That's a very empowering thing. I think it's very aligned with DevOps, and it's a practice I've seen where teams own their own recovery. I think can be very powerful. And use incremental backups, all right? So it might take an hour to back up your database, and then it does incremental backups of just what's changed, and those only take 15 minutes. This allows you to get lower recovery point objective. Because if your database if you aren't using incremental and it takes an hour every time to do a backup, guess what's the lowest RPO you can have? An hour, right? So with incremental backups, you can get those better RPOs. And this is one I don't have too much to say on, but it's important, is encrypt everything, right? In transit, at rest, make sure your data is encrypted. And this is important. This might be the last one in the series of requirements, but it might be one of the most important ones. Testing and measuring. Again, a very DevOps kind of thing. You see people that have, I talk to people that say they have a disaster recovery strategy all the time and they just have backups. And I say, have you tested it? And they said, yeah, we recovered the backups. I'm like, that's nice. Have you recovered everything? Either no or yes, and it took us 4 days to do it, right? To get everything all set up, right? And it's really painful and we don't like doing it. I've said for years that if you have a disaster recovery strategy and you don't test it, guess what? You don't have a disaster recovery strategy because the chance of that thing working when you need it, when the chips are down and all this, the you-know-what is hitting the fan is pretty much zero, right? So let's talk about testing. Number one is full recovery during test. Not tabletop, not just data. Everything gets recovered during a test. Number two is while we're testing, we still continue to take backups, right? It's important that we continue to protect that source workload. Number three, network sandbox or bubble testing. All right, this is not always a requirement, but having the capability is important. So we find that some workloads, when you recover them, even in a different region, even in a different account, have the potential to interfere with production. Not all, but some. And if you could put a firewall around that, that gives you that safety margin, so you don't have to worry about that. And the last requirement for testing, maybe the most important requirement for testing, tear it all down cleanly, right? After you're done testing, your disaster recovery strategy should tear down everything it doesn't need so you're not paying for it and you're not leaving orphaned resources lying around. That wasn't the last requirement. The last requirement is multiple recovery points. Why multiple recovery points? Because if it's a ransomware attack, your last backup is full of encrypted garbage, right? So you need to actually be able to go back in time to a time before you were attacked by the ransomware and recover that. On the left is just a retention policy, a simple retention policy you might consider that gives you a lot of flexibility on how many backups to keep over what time range. Okay, that was the last requirement. So time to dive into design and implementation of disaster recovery that works. And for that, I want to introduce you to the shared responsibility model for resilience. Now, there's a lot of text in the model, but I really just want you to concentrate on one thing, that there's a line, and below the line is AWS or the cloud provider's responsibility, and above that line is the customer's responsibility. You don't have to read the boxes. I'll tell you what the responsibilities are. AWS's responsibility is to provide reliable services and fault isolation boundaries, like regions, that you can use. So what's your responsibility? To use those things, to build those things. Remember the best practices I showed you in the well-architected framework? That's your responsibility, is to follow those best practices, to implement disaster recovery strategy. I don't know how many people I talk to that say, I don't need a disaster recovery strategy, I'm in the cloud. I'm like, no, that's not how it works. Nobody's going to do it for you. You have to build it. And this line can move, right? So here we are, what I call the hard strategy, because the line's really low. That means your customer has a lot of responsibility. Below the line, I'm making use of AWS's native primitive, not primitive as in bad, but primitive as in applied to each resource type, backup strategies, right? The backup for a volume, the backup for a server, the backup for a database. AWS gives you that capability, but look what's on top. I'm not going to read everything, but look, you're going to have to identify every data source you have, back it up, make sure the backups are copied, and then restore each backup separately. That's the first 3 bullets on there. And then the bullets just go on, right? So a lot of customer responsibility with this model. Totally doable. I'm not saying good or bad. I'm just saying you're taking on a lot of work here. Raise the bar. It's something we used to like to say at AWS and Amazon a lot. Raise the bar, right? Okay, so we raise the bar. Now, instead of using the primitives, we're using the higher level services. We can use something called AWS Backup. And again, all cloud providers have something similar. I mean, I think in Azure, it's called Azure Backup, right? So now you don't have to maintain backups for every individual thing. You have a single pane of glass. You can set up these backup vaults. And notice those first 3 bullets went away and are replaced with manage the backup plan. So it got simpler, right? You're using these higher level services. So this is medium. How do we make it easy? Okay, I keep going back to this automation and orchestration. Right? You can build the automation and orchestration of those primitives, of those higher level services, so that at the push of a button, you can recover. Now, I work for a company named RPO, and we have built that orchestration and automation. And I want to share with you the examples of how we implemented it so you can learn from our design and even learn from our mistakes, right? And you can see how to build something like this. So the first thing is you need to be able to copy your data, copy everything honestly, but copy your data cross-account and cross-region, right? And here I'm using a file system. And, it's the FSX. It's one of the AWS file system types. I'm using a file system. And the thing to know about this file system is that there is native support for backing it up and copying it cross-region and cross-account, right? So that exists. So what do we have to do then? There's native support for it, right? Sounds easy. Not quite. Step one is it's currently encrypted with a key that AWS owns. That key cannot be transferred to a different account. So I'm going to have to first re-encrypt it with a key that I own, a key I create on the recovery side. So I create a key on the recovery side, and I could do this with cross-account access, and then I re-encrypt my backup with the recovery side key. That means I also move it to the new region that I need to go to, right? That means now when I copy the backup to its final destination, its recovery site, it's now encrypted with a key that is usable in that recovery site, which means that when it's time to actually recover, I can recover that database, and it'll have the right key that is accessible in that recovery site to be able to be read by services in that site. So there's still work for you to do. Even those native capabilities, there's still work for you to do here. Now, let's take something that doesn't have native capabilities to copy it. In AWS, there's Secrets Manager secrets. In Azure, there's Key Vault entries, right? In AWS, there's SSM parameters. There's Kubernetes manifests, right? But in any cloud you're in. These are things that don't generally have native backup capabilities. So what can you do here? Again, I'm going to share how RPO designed it, and you could design something very similar. So RPO is sitting up on top as a SaaS. In your case, it's not necessarily, you don't have to build a SaaS. You can just build some orchestrator, right? But the key is inside the yellow. Inside the yellow, we put lambdas, which you don't know what lambda is. It's serverless compute. So we put some code in each account. The source is on the left, the recovery is on the right. And now that code is going to kind of replicate what I showed you on the previous slide. The lambda on the source side can read the secret. Can the orchestrator on top read it? No. So it never gets exfiltrated. It's a lambda inside the account can read the secret and create a key on the recovery side and encrypt the secret with that key, then stuff it into a bucket or blob storage on the recovery side. And now it's where you need it. It's encrypted using a recovery key in the recovery side. And so when you need it, you could stand it up and you have access to that secret or parameter or manifest. All right, that's enough on copying things across accounts. Let's talk a little bit about endpoints. I mentioned this a little bit earlier. Any of these resources you see here, databases, load balancers, file systems, they have DNS endpoints, right, that are generated by the system on your behalf, right? And whether you're restoring something from backup or creating it brand new with infrastructure as code, that endpoint name is going to be different than it was in the source. It's just a fact of life. You're not going to have the same endpoint name. So that means that you look here, it's a little bit small, but you can see there's like, on the source side, there's a server calling a database, and the database's endpoint is named AAA, and the server knows that, and it calls the database, and everything's happy. But when we go to recover it, that database now has the endpoint ZZZ. And the server, which has just been recovered, backed up, and restored, just still thinks, I need to talk to AAA, and it doesn't work. So what can you do here? Well, one thing we did is we implemented something called private hosted zones or private DNS. This is DNS resolution that only exists inside the virtual network. It's not public DNS, but it's private DNS that uses a CNAME record to map the old name to the new name. So in this case, the server is calling AAA. Private DNS says, oh, that resolves to ZZZ, and then sends it on its way to the database, and now you have connectivity. Now, there's other things you can do here, right? You could actually go write a script to go in and remap all those endpoints and tell all the applications the new endpoints. So that's another option. But the private hosted zone I thought was a pretty clever one. It works really well. And let's talk about databases. Your database has a password, right? You rotate that password, right? Right? I'm not seeing a lot of nodding here. OK. You rotate that password. So that's what those little clocks are showing, that over time, the database password changes. And on the source side, you might be storing the password in a secrets manager or key vault, whatever. And the key vault or secrets manager changes, and database password changes database, and it keeps in sync, right? What if you're restoring a database from 4 days ago? You had a ransomware attack. When you restore that database, it has the blue password because it's from 4 days ago. But you don't have access to the blue password anymore. It's been rotated out. Like if you look in your own secrets manager, if you can get access to it, even because of ransomware, it has the most recent password in it, the purple password. They don't match, right? So what do you got to do here? You got to take this into account. What we've done, what we decided to do is back up everything as a time-consistent recovery point, is what we call it. So not just data, but infrastructure, passwords, networking, everything is all inside that recovery point box is all recovered at a certain consistent point in time and encrypted. So that when you recover it, on the recovery side, you get the password from 4 days ago and the database from 4 days ago. And now it's consistent. Other options here is if you have admin access, most systems will let you reset the password after you recover it. So you're going to have to recover it with the password you don't know and then tell it to reset the password. So that's another option. But then when you do that, you have to tell everything that uses that password or the secrets manager secret or the key vault, whatever, what the new password is. And I keep making the point that things change in recovery, and that's my biggest takeaway. Things change in recovery. So here are the names of things, the resource names, the endpoint names. In AWS, they have something called ARNs, which are resource numbers or resource names. But every cloud has these. Source on the left, recovery on the right. They're different. And I already showed you how to handle that using private hosted zones for endpoints. But in general, there's a lot more things other than endpoints that change. So how do you handle that? So a little bit of an eye chart here. What you're looking at on the left is user data, cloud init user data. So for those that don't know, you can set up scripts that run when your servers come up in the cloud. That's what this is. Okay? And what I've done here is I need to reference an S3 bucket, blob storage. I need to reference a private hosted zone. But instead of referencing it by name, I reference a parameter. You could parameterize these things, put them in a parameter store, and reference the parameters instead. So if you look on the right, if your recovery system knows this, it knows to go through each parameter and change it. In this case, changing it from Eliot S3 bucket to Eliot S3 bucket -dr. So now the script, when it runs, doesn't change. It just references the same parameter. That parameter has the right value in it, the translation. And we take this a step further. We don't make you parameterize it. We prefer you do. But even if you haven't, so there's a file system endpoint being referenced raw, not a parameter. We actually make sure to go through all the EC2 user data and translate it, you can see on the bottom, to the new name. That translation is so important. And as a matter of fact, if you look on the screen, these are all the places you need to do translation. In EC2 user data or cloud init, whatever you want to call it, in environment variables, in task definitions, route tables, IP numbers will change. In policies, the names of things that, I want to give permission to this database with this policy. Well, guess what? The database has a new name. So you need to change the policy. These are all the things that need to be translated and updated if you're going to do disaster recovery. And that's the implementation part of it. So let's just sum it up a bit here. Being a DevOps conference, I definitely want to talk about, hopefully you already saw it. Hopefully it doesn't, you already saw how this is very aligned with DevOps. But I really want you to build a culture of resilience on your teams. Make sure the resilience objectives are clear. And those resilience objectives are a shared responsibility between the tech teams and the business teams. When I was talking about RPO and RTO, I forgot to mention this, but guess what? You need to talk to your business team. You shouldn't just be deciding what the RPO and RTO is yourself. And you should inform them. I like to joke that if you ask your business team, what should my RPO and RTO be for this workload, they're going to say 0. We want to lose nothing. We want to be down 0. So it's your job to inform them, okay, yeah, that's possible, but here's how much it's going to cost and how long it's going to take, and it's going to be difficult to maintain. Or you could have 15 minutes and an hour, and here's what it's going to cost and what it's going to take, and they might choose that. All right, everybody knows you build it, you run it. I stole that and said you build it, you recover it. Automate almost everything. So again, I'm a big fan of orchestration and automation. Can anybody guess the one thing I say we should not automate in disaster recovery? No guesses? What's that?
Testing?
No, I like automated testing, but the actual decision to switch over, right? I like to have a human in that loop for 99% of the cases. I like to say, if you have the simplest, dumb, static website in the world, sure, automate failover. And if you have the most sophisticated metrics and logging in the world and you think you can actually determine some kind of signal that tells you, yeah, it's time to fail over, maybe automate failover. For everybody else in the middle, have a human in that loop. Have highly automated recovery, highly automated failover with human initiation. All right, and test and measure frequently. Obviously, a big deal. So in summary, I tried to make the case here that we're going beyond backup. And the reasons we're going beyond backup is backing up your data and recovering. That's great. But beyond backup means recover everything, not just the data. Recover to a safe, isolated environment. Now, backups often do that, so I'll give it there. Understand your dependencies and configuration. Well, I kind of banged that drum a lot. Hopefully you get that now. Make it self-service for teams to onboard. I love the platform model. I love empowering teams. Make it easy to recover, make it push of a button, and enable frequent test and measurement. Bit redundant with the previous slide, but again, just showing how I like to say that this is what you need for DR. And with that, I'd be happy to meet with you to talk about your disaster recovery strategies. It doesn't have to include RPO at all. I just love talking resilience and disaster recovery strategies. Feel free to book some time with me. And I believe I have time for questions. All right, so if you have a question, just raise your hand and a mic will be brought to you.
All right.
Thanks. So everybody could probably improve in this area. My team's doing okay-ish. We use Terraform for provisioning everything, and we test annually. So we do a Terraform apply in a different region, restore everything, make sure the application is functional. My security and compliance team says a year is a long time to go without testing the integrity of your backups. And I say we use AWS Backup. You said test frequently. How frequently do you recommend?
That's an it depends answer, right? It sounds like testing is painful for you, right? That's why you only do it once a year. Yeah, so I mean, I want to see testing once a quarter. And I want to make it easy. I don't want you to go through the pain once a quarter. I want to make it easy, and so easy that it's not a pain to do once a quarter. But it's debatable. I mean, once a year does seem a little long, though, doesn't it? It's not the integrity of the backups that worries me. I mean, you just said there aren't a case about integrity of the backups. We're using AWS Backup. The integrity of backups doesn't worry me. Right. It's the putting it all together and making it work that worries me. All right, another question?
Oh.
You spoke about failover. The failing over from one account to the other.
Yeah.
Right. So my question is, does that go all the way up to the master payer account? How does that factor into that account
It's a
structure?
great example. We actually have, I'm just referring to my own experience with customers. For many customers, they're happy just going from one account to another in the same organization. It's always layers of defense in resiliency, right? So that means you're protected against most things, but you're not protected against someone getting access to your master payer. In that case, everything's compromised. But again, the chance of them having access to the master payer is lower than them having access to the account. So again, layers of defense. We do have some customers that go cross-organization. And just to promote a little bit, that's not something natively supported by AWS, but we support that. So, and if you build it, you need to support that if that's a business requirement.
I think we have time for one more question. Oh.
Yeah, go ahead.
Oh, maybe we can do two. We'll see.
Yep, go ahead. Close it up.
That bubble environment that you build, is that the same environment that you would fail over to if you were doing a disaster, or is that just for your testing?
It's the same environment you'd fail over to during a disaster. The only difference is we're putting that firewall around it. So that's what makes it a bubble. That's what makes it a network sandbox. But other than that, it's the same environment. Because obviously when you're testing, you want to be as close in fidelity to what would actually happen in the real thing as possible.